Hey guys, so this is linear optimization. So this is part one of a two-part video because it is one of those more technical lessons. So the first thing we have to discuss is this word optimization. Okay, you might be thinking Optimus Prime, leader of the Autobots, the coolest guy out there, and you are correct. Okay, optimizing something is trying to find the best of something. Okay, you want the most money. Okay, you want to optimize your profit. That's the biggest thing. You also want to limit your downtime or your cost on items. So this is actually used by businesses a lot to you find the best way of running the business. So Frito-Lay does this with what chips they need to run. Now we're going to do some simplified versions of this. Frito-Lay has like 24 different variables that they deal with as far as what the corn is, how much oil, how much seasoning they need, and how long can the fryers run for specific like chip, like Doritos, Cool Ranch. How are we going to make the most money and limit the amount of downtime? So this has huge business ramifications for us. So we're going to do some simplified versions, and then we're going to get into some of the real-life word problems. So this video is just going to go over the very fundamentals of it, the skills of it. So I'm calling this Tier 1. Okay, and that is to find the maximum and minimum values of a function over a region. Okay, so that is using those linear inequalities that we've been doing. So again, you're trying to find the maximum or minimum for a given situation. So you always want to maximize profits or minimize cost. So that's why there's two things. And they're always set by constraints. So some people can only work so much, okay? Generally, by law, people aren't supposed to work over 8 hours without a lunch break. That's a constraint that people have. People can't work more than 40 hours without being overtime. Companies don't want to pay overtime, so they want to keep it under 40. Okay, so that is minimizing costs, and that's setting constraints on the function. So what we want to do is we're going to figure out all our constraints. We're going to graph them. We're going to figure out the feasible region. Now, you guys have been doing some feasible regions, okay, and it's just linear inequalities. So remember that shading area is that feasible region, okay? Each one of these lines is what we call a constraint. So what we want to do is we want to find that feasible region. After we find that feasible region, we figure out where they're crossing, okay? Where the systems are equal. And that is where we're going to find our minimum or maximum values, okay? Some are going to look like this, where it's bounded or everything's inside. Some are going to be unbounded, but there's still the constraints and the vertices. Okay, something happened there. All right, technology is my friend. So the first step is to recognize our inequalities. Okay, you're always going to be graphing inequalities in this section. So the first step, again, y equals mx plus b. Again, b is the number without the x, m is the slope. So in this case, this 1 is the b, and my m is -1. So again, I just plot this. Okay. I try to draw a straight line, okay? And this means that I'm going to be shading above it. So this is my purple line. Okay? Now, for this one, it's written traditionally. I'm going to change colors here. We're going to minus 1. My slope is up 1 over 1. You'll notice I already have one intersection point right there. They cross right there. Okay? And then I have this third, which is an x equals line. So we have to remember, anytime it's just x is equal to 3 or 4 or less than 3 or whatever, that's that vertical line. Okay? This is a reminder. When it's y is equal to 3, it's that horizontal line. Okay? Just remember that when you're doing these things. So in this case, it's x is less than or equal to 3. So I'm going to go over 3 on the x. I'm going to draw a vertical line. Okay? I now know that, I forgot to shade this orange line. The orange line is shaded below. And this green line is shaded this way. So you might be confused because it looks very hectic in there. So you definitely want to draw lightly and erase the stuff that doesn't overlap. Okay? What you will find is it creates a small triangle in here, bounded by these points. And that's what you're looking for, is where are they crossing. So what you do is you just label those points. So I know one of those points is 1, 0, right here. The other point is going to be 3, 2, right here. And the third point is going to be 3, negative 2, right here. Okay? So now we found the vertices, we're good. The trick with this one, again, you need it in y equals. Okay? So I'm going to give you a few hints here. Rewrite this equation. Okay? And this is where the common mistake comes in. I got to get rid of the x on this side. I'm going to subtract it. You notice I carried down that negative sign? I see so many people mix up, they don't carry that negative sign down. And now I have to divide by negative 1. And y, divide by negative x minus 2, because they changed signs here. Remember, when I divide by a negative, I have to flip the inequality. The second one is a little bit easier. If I'm subtracting x, this positive comes down, so I just leave it as y is less than or equal to negative x plus 2. So I'm going to leave you with those two equations in this one to find the vertices. So that is part of your practice. The linear programming comes in when you have to graph this, okay, and then they ask you, find the minimum or maximum values of the function for this region. Okay? Now you'll notice this is a typical equation, this is a typical equation, this is a typical equation, but this is something weird. Okay? Because it's f, or a function, based on x and y. So x and y, that's a point. This is what I call the maximizing function. That is what I'm going to use to find the maximum or minimum value. This is also going to be known as our profit equation or our cost equation. So the first step in all of this is graph the inequalities and locate the vertices. So you might be confused on this because it's a double inequality. Whenever you face something like that, you have to split it into two things. 3 is less than or equal to y, and, remember the compound inequalities from our Algebra 1 skills unit, y is less than or equal to 6. So these are horizontal lines 1 through 3 and 1 through 6. And it's shaded in between them. So I'm looking for stuff in between here. Okay? Now you might need to make each one of yours too because we ran out of room. So now I'm just going to graph these two other equations. So this one is a little odd, okay, because it's going to go off the graph, okay? So I'm just going to estimate 1, 2, 3. That's going to be where 12 is, okay? I can go up 3 over 1, or I can go back down over 1, back down over 1, like this, okay? And I get this line right there. Now, where is this one shaded? It is less than this. So it's everything, right now my region is in here, okay? Because it's in between these lines and over this way. Now I graph this equation. I go up to 6, boom. I go down 2 over 1, down 2 over 1, up 2 over 1, okay? Boom, okay? Y is less than this, so it's below this graph. My region is in here, okay? I'm left with 3 points, okay? Those points are, okay, 0, 6. All right? It is -2, 6. Right? This point right here. Okay? It is -3, 3. And it is 1.53. So what I do with those points that I find is that's where this equation comes in. All it says is I'm going to take each point and plug it in for x and y, and then just solve. Okay? So this one would be 4 times 0 minus 2 times 6. So that would be 0 minus 12, so that's -12. All right? 4 times -2 minus 2 times 6. Well, that's -8. That's -12. So that's -20. 4 times -3 minus 2 times 3. -12 minus 6 is -18. And then 4 times 1.5 minus 2 times 3. 4 times 1.5 is 6. Minus 6 is 0. So, what you want to do is, okay, what is the maximum value? Well, the maximum value in this case, well, all these are negative, this is 0. That's my max right here. My max value is 0. My minimum value is the largest negative, so this is my minimum value, is -20. So that is how I process through the tier 1 problems. Is I have to graph them, and then find the vertices, okay? And then I take my maximizing function, and I plug it in, and those vertices, and I find the minimum and maximum points. So if you could please, okay, try and do these two. Okay, remember, this is a split inequality, okay, where it is like this, okay? And those are vertical lines, all right? And after you guys are done with those two problems, then check your answers, and then go on to tier 2.